Good to have you back. Today's lesson, we're going to continue with the scientific toolkit unit, and we will know everything that we need to know about unit conversion and dimensional analysis, where we have to use dimensional analysis to get the unit conversion correctly. All right, and we have to show our work. I set up here a few unit conversion for you already, but there are many more. I just chose a few and I wrote it up here for you to see. And some of them are very interesting, some of them are not. For example, this one light second. I don't know if you knew that or not. That's 300 million meters. Remember, light second is a distance, is a measure of distance. If you're taking physics, you will know this for sure by the end of the course. All right, for sure you will know this. All right, let's go through some examples. We're going to do 3 or 4 examples. First one, 100 years into days, then into hours. And this is a very good question, actually, that how many days do we actually live if we live to be 100 years old? So here it is. We're going to go through the dimensional analysis. So this is very simple. Everybody knows that 100 years, I'm going to put y, and we're going to go multiply by. Now, remember, we want to get rid of the year. We have to use the ratio where y, or the year, is in a denominator because the original year is in the numerator. And then we're going to change that to days. How many days in a year? Well, in a day, so that's a day on top. There, in 1 year, this got 365 days. Now, I understand it could be 365.23 days, but we're not going to do that. Forget about the leap year. Just use 365. Now, we are if we want to just stop at the days, this would be it. Okay, we can actually do that. See how many years that is, and that is basically 36,500 days. Okay, and if you want to change that from days to hours, then you're going to go through 36,500 days times, and then we do the dimensional analysis again. Now this time days will go to the denominator. 1 day, how many hours? We have 24 hours. And now you just multiply the number. Now for the practice, let's leave our answers, if we can, in some cases, as in scientific notation. Okay, let's do that. So let's multiply through and find out. So we'll get 87630. That's 876,000 hours. Okay, or 8.76 times 10 to the power of 1, 2, 3, 4, 5, right? And that would be to the power of 5. All right, so that's the scientific notation, 3 sig figs, and that would be the number of hours that we have. Excellent. Now, if the question was you go from 100 years directly to hours, then you can just use this and add that here and continue it in one smooth continuous calculation, and you will end up getting the same answer. Okay, all right, let's do another question. 2,678 centimeters into feet. So let's write up 2,678 centimeters times, and then we're going to start with the centimeters. Now go back to the table that I created. Do we have direct centimeters into feet? If we do, then that is great. But if we don't, we have to use an intermediary calculation or conversion rate. Then we go from there. So notice that inch we do have, and then after inch we can go from inch to feet, which is right here. Okay, so we can do that. So from centimeters to inch, 2.54, 1 inch. So we can do inch on top. We do 1 inch, 2.54 centimeters times, and now we're going to get rid of the inch. We're going to put feet on top, and we know 1 foot. In this case, we're going to do foot. And what do we have? 12 inches for 1 foot. Excellent. Now that we have this, we're going to go through and notice that just like the last question, when you do the dimensional analysis, you divide the units, and whatever the units is left, you end up having that unit. So here we do the same thing. Centimeters divided by centimeters, that's gone. Inch divided by inch is gone. What you are left with is foot. Okay, let's do the math. And we got 87.86 feet. I left it as 4 sig fig. Not that we know what this is. This is, again, it's kind of ambiguous. We don't know exactly how many sig fig that is, but I chose the 4, so I left it at 4 sig figs. Okay, now you can change that to scientific notation. Sure, let's do that. So this would be 8.786. We're going to maintain the 4 sig figs times 10 to the power of 1. Okay, and that is the feet. Excellent. All right, let's do another one. 100 yards per hour into inches per week. So this is the compound or rate conversion within the unit conversion. So let's go ahead and do that. This is a typical for chemistry and physics students that you need to know. You need to be able to do these very quickly. All right, let's start out with 100 yard. I'm going to put y divided by h, that's yard per hour. Okay. Now we're going to do the dimensional analysis. So here it is. We're going to do one thing at a time. First, we're going to get rid of the numerator, which is the yard. So the yard is on top. We have to put the yard in the denominator of the new ratio. So the first one is the yard. We want to get inch. So 1 yard is how many inches? We're going to go back up to our table again. 1 yard, how many inches? Do we have that? We don't have that. We may have to change that to feet first, then from feet to inches, right? I don't think we do. No, we don't. I can just say it, but no, I don't want to. Let's do that. Would be a perfect practice. So 1 yard is 3 feet. So let's go through the yard first. So we go yard and feet. So that's 3 feet. And then from feet, I'm going to put it feet there, and then inches, that's 12 inches. So we just took care of the yard. Okay, so we can just do that and do the calculation there. We can technically stop right here and then get whatever we get and then deal with the hour. We can do that. All right, or we can continue. So multiply again. Now we're going to deal with the hour. This one down here, hour. Well, we want to get rid of this hour. We're going to put the hour on top. So, and then we want it for week. Well, this is the part that you have to be careful. So let's do hour and day. So 1 day is 24 hours. And then we want to get rid of the day and then bring the week in. So we say day on top, week on the bottom, 1 week, 7 days. Okay, so that's what we have done. So we have days here, we have hour there, days, and week. Okay, now we're going to go and put it together. So now we're going to do the multiplication. First, notice that we are going to get rid of all the other units. The yard and yard divides. We have feet and feet divides. So we will end up getting only inches here, which is right here. The next, we're going to get rid of the hour and hour. We are getting rid of day, and what we will have is week, which we have week there. So our answer will end up being inches per week. That's what our answer will be. And in this case, we're going to multiply all the numerators, whatever we get, divided by the denominator. But notice that the denominators are all 1. There's nothing there except 1. So we just have to multiply right through. All right, the final answer will be 604,800 inches per week. Now let's change that to scientific notation. So this will be 6.04800 times 10 to the power of, and let's see, what do we have? We have, if that's a decimal point right there, so we bring it in 1, 2, 3, 4, and 5. 10 to the power of 5, and that is inches per week, and that's the conversion for working 100 yards per hour. Supposedly, either you're cleaning it or you're mowing the lawn or whatever that is. Okay, so here is the three questions that we used. There's some of them are involved, but perfect practice for unit conversion through dimensional analysis. Okay, make sure you check out the next video in the series. Until next time.